Okay guys, welcome sa ating YouTube channel. For this video, ang topic natin ay about sa slope-deflection method, application naman for beams. Okay, so we have here 3 examples for this video. So for our first example, determine the reactions of the beam shown using slope-deflection method. So sa part 1 ng ating discussion about sa slope-deflection method, dinerive natin yung ating gagamitin na slope-deflection equations. Second part naman, dinerive natin yung mga common fixed end moments. Okay? So, for this video, straightforward na tayo, no? So, meron tayong 3 spans, AC, CE, and EG. So, kada span na to, meron kanya-kanyang fixed end moments. Okay. FEMAC equal yung fixed end moment sa FEMCE or sa CE, which is positive 115.2 kN meter. Ibig sabihin, dahil positive, counterclockwise yung rotation. On the other hand, FEMCA is equal to FEMEC, which is negative. Okay, 172.8 kN meter. So, para di kayo malito, kung saan mas malapit yung load, mas malaki yung moment doon. Okay? And then for EG, we have 150 kN meter. For GE naman, negative 150 kN meter. Okay, so please take note of these values. Punta tayo rin sa ating slope deflection equations. Okay, so meron tayong 3 spans, so expect natin meron tayong 6 na moment or slope deflection equation. So here are as follows. Okay? So, yung delta rito will be 0 kasi wala namang support displacement or support settlement. Therefore, pwede natin i-cancel yung value dito. This will reduce to this one by substituting also the lengths per member or per span. Okay? Yung AC, 10 meters. Yung CE, 10 meters. Yung EG naman ay 8 meters. Take note also that the moment of inertia dun sa member or span CE ay twice ng moment of inertia ng AC tsaka ng EG. Kaya sinubstitute natin yung 2i dun sa value dito. Okay? So upon simplification and substituting the values of fixed end moments na nakuha natin kanina, okay, magiging ganito yung ating moment equations. Okay? Or slope deflection equations. Okay, so let's have our compatibility conditions. Ano ba itong compatibility conditions na to? It comes from the equilibrium equations. So, kung babalikan natin yung ating beam kanina, you can notice easily that moment AC should be equal to 0 because unang part yun ng ating beam. Mag-i-start talaga tayo sa 0 moment. Okay, what else? Yung sum ng moment CA tsaka moment CE equal din dapat sa 0, which means yung kanilang numerical value ay parehas, magkaiba lang ng sign para balance yung moment dun sa point na yon, specifically at point C. So as with point E, moment CE plus moment EG should be equal to 0. And lastly, dahil dulo naman din na to yung point G, so MGE or moment GE should be equal to 0. So by substituting yung MAC tsaka MGE, okay, magiging ganyan yan na. And then unahin natin yung MCA tsaka MCE. Take note yung sum nila ay 0. So ipag-add natin yung dalawang yan. So yung left side ng equation natin, take note from the compatibility conditions, 0 yung sum. Okay, and combining like terms, okay, specifically yung EI theta C will become this one. Okay, you can counter check the values. Next, add natin yung dalawang to, yung MEC tsaka MEG. Okay, so we have what? This one. So if you notice, meron tayong ilang unknowns dito. We have 4. EI theta A, EI theta C, EI theta E, and EI theta G. So we have 4 equations for unknowns. You can use any mode of solution, Gauss-Jordan, Gaussian elimination, even your calculator kung kaya ng 4x4, pwede rin Excel. Basta magawa natin ng paraan para masolve yung lahat ng to. So in this case, we will be straightforward. EI theta A is negative 356.98. EI theta C is equal to positive 137.96. EI theta E is equal to negative 91.391. And EI theta G is positive 345.695. Okay. I prefer to substitute the exact values. Kasi pagdating dito, pag substitute natin ulit dun sa Slope-Deflection equations natin, mas magandang sakto yung isa-substitute natin so that we can see that MAC is really equal to 0. You can counter-check that, no? MCA, upon substituting the pertinent values, you arrive to negative 189.012 kilonewton meter. So, we expect dapat yung isa, MCE, ayan, dapat positive. Kasi nga, yung sum nilang dalawa ay equal sa 0. You can counter-check the values, guys. No? Next, punta tayo sa MEC. By substituting the values ng theta E tsaka ng theta C, we have negative 190.728 kilonewton meter. And MEG is positive 190.728 kilonewton meter. Then yun, MGE is equal to 0. Okay, it is an evidence that the moment or the internal moment at the interior supports, given that walang binigay na moment doon, will become negative or will be a negative moment. Okay, usually ganon, but there are exemptions to the rule. Okay, kapag mayroong applied moment doon, usually nagkakaroon ng positive moment, pero napaka-rare nun. Okay? So, let's proceed. Okay, we are going to use method of superposition. Okay? Gagawin natin, iisa-isahin natin yung kada member, then kukunin natin yung reactions due to the loads per span. Okay? So, we get 48.72. Same lang din dito. And syempre, obvious naman natin 75 kilonewtons to. Okay? Next, ilagay naman natin ngayon yung mga nakuha nating moments doon sa ating slope deflection equations. So, ilagay natin yung 189.012 kilonewton meter. Take note that this is what? Kanina, negative. Okay? Kaya, by our sign convention, yung negative ay clockwise. Kasi, yung positive natin ang counterclockwise. So, everything will follow. Okay? Then, so as for this one, and with this. Okay. So, paano natin kukunin yung reactions dito? Take note that these are all moments. So, dapat ang mag-resist dyan ay couples. Take note that couples are forces with equal in magnitude, opposite in direction with a perpendicular distance between them. So, dahil yung 189.012 kilonewton meter ay clockwise, therefore it must be resisted by a counterclockwise couple. It's like this. Yan. So, ano kaya yung value? 189.012 divided by 10 meters. Okay, kasi nga 'di ba moment is equal to force times distance. Okay? Then dito naman sa span CE, kung papansinin niyo, 189.012 is counterclockwise, then sa point E 190.728 clockwise. So therefore, dahil mas malaki yung magnitude ng 190.728 kumpara sa 189.012, okay? Mas mangingibabaw yung clockwise. Okay? So 190.728 minus 189.012, subtract natin yun mamaya later on. But the point here is, yun ang ibabaw na moment ay clockwise, therefore it must be resisted by a counterclockwise couple. Ayan. And for EG, Dahil counterclockwise yung moment, dapat clockwise yung rotation ng couple. Just like this. Okay? So now, 189.012 divided by 10 meters, we can see that this is what? 18.9012 kilonewtons. Okay? The next, 190.728 minus 189.012, kung ilan man yon, divide natin ng 10, that is 0.1717 kilonewton. Maliit na lang yan kasi 1 point something lang yung difference ng dalawang yan. And this one, obviously, dahil 8 meters yan, 190.728 divided by 8 meters, roughly ganyan. 23.8411. So, what's the essence of this? Pwede natin i-sum up lahat yan. No? Lahat na nakatutok sa A, yun yung magiging reaction sa point A. Yung sa ating original na beam. In this case, itong dalawang to. We just need to follow the arrowhead na naka-indicate sa kanila. So, this will become 48 minus 18.9012. And that is equal to what? 29.0988 kilonewtons. Okay? For letter C naman, lahat ng nakatutok sa point C. And these are these 4 values. So, kung sasum up natin yan, we will get 138.7295 kilonewtons. So, as with point E, okay, additive lahat, no? So, we have 171.0127, and for last, point G, 75 minus 23.8411, that's 51.1589 kilonewtons. So, upon checking, we can see that this is in equilibrium, summation of forces vertical and summation of moment at any point. Okay, so for presentation purposes, ito po yung mga reactions sa beam na to. Ito rin yung mga nakuha natin na values. You can counter-check na by summing up moments at point A kung talagang ang moment dyan ay 0. Okay, let's go to our second example. Determine the support reactions of the beam shown using the slope-deflection method. In this case, ang loading lang na naka-apply sa beam na to ay clockwise na 150 kilonewton meter at joint number 2. Okay? So, ibig sabihin, wala tayong makukuhang fixed and moment sa kahit saang part ng beam. Therefore, FEM12 equal to 21, 23 equal to 32, and 34 equal to 43, all fixed and moments are equal to 0. Okay, wala tayong masyadong worry dyan. Ha? So, ilagay natin yan sa ating slope deflection equations. So, dahil walang support displacement, 0 lahat ng delta 1 dito. Or, sorry, ng delta, no? Delta 1, delta 2, delta 3, lahat yan 0. FEMs, lahat 0. Okay, so cancel natin. Malitira na lang to. Okay, simplify pa natin ng further. So, yan yung mga makukuha natin na values. Okay, what will be our compatibility conditions? First, may moment sa 1, 2. Okay, kasi fixed yun eh. So, as with 4, 3 later on. Ano yung makukuha natin na condition doon? Take note, that is a fixed support. Therefore, the slope there must be equal to 0. So, yun yung ating makukuha na compatibility condition sa fixed support. X1, moment 2, 1 plus moment 2, 3 is equal to negative 150. Bakit negative? Mamaya malalaman ninyo kung bakit, no? Okay. Dahil walang naka-apply na moment dito, that is equal to 0. Moment 3, 2 plus moment 3, 4 is equal to 0. And lastly, theta 4 is equal to 0. Okay, bakit kaya negative yung 150 rito? That is because we're going to follow our sign convention. Okay, kasi clockwise yung moment na yun eh, yung 150. Okay? So, kailangan nakaayon tayo palagi sa ating sign convention. So, by substituting lahat ng 0, magka-cancel lahat yan, this will reduce to this one. And adding these two, Take note, equal yan sa negative 150. Okay? And adding this 2 will yield to this one. Okay? So apparently, meron tayong 4 equations for unknowns. But we can actually use the second and third equation solely. We're going to solve for the values of EI theta 2 and EI theta 3 as follows. Okay? So we have EI theta 2 is negative 120 and EI theta 3 positive 30. Set aside natin. I-substitute natin para makuha yung values ng M12. We get here negative 40 kN meter. M21 is negative 80 kN meter. M23 negative 70 kN meter. Kaya kung titingnan natin, negative 80 plus negative 70 is negative 150. Yun yung kailangan natin makuha dito. Okay. Itong dalawang to, yung 3.2 tsaka 3.4 dapat same ng magnitude na 20. Okay ba lang ng sign. Okay, so 20 kN meter na negative yung moment doon. And mg is positive 10 kN meter. Okay? So, dahil wala namang naka-apply na load doon sa ating beam, okay, doon sa kanilang entire length or doon sa kanilang length, na we can now proceed by putting the moments. Okay, this is 40 kN na clockwise. Bakit po? Negative kasi yun doon. We need to follow our sign convention. Please refer na lang po dun sa ating part 1. Negative 80, kaya clockwise din. 70. Okay, negative din yun. Kaya clockwise dito. Yung 20, clockwise din. Hindi ko nagkakamali. Okay, dito, positive na siya. And then dito, positive din yung 10. Okay? So, for span 1, 2, same na clockwise. So, additive ito. Parehas clockwise. So, therefore, it must be resisted by a counterclockwise couple like this. 70, tsaka 20, parehas clockwise. So, dapat counterclockwise yung couple. And dito naman, 20 tsaka 10, parehas counterclockwise. Kailangan clockwise yung couple. So, 40 plus 80, 120 divided by 6, obviously that is 20. 70 plus 20, 90 divided by 6, 15. And 20 plus 10 is 30 divided by 6, that is 5. So, tutok natin lahat sa bars na yon. We can see that at point 1, isa lang yan. So, we have a 20 kN load or reaction downward at point 1. So, point 2 naman, 20 minus 15. So, that is 5 kN na upward. Dito naman, 15 tsaka 5 na parehas upward. So, 20 taas. And obviously, 5 kN na pababa. So, dito pa lang sa reactions na to, makikita mo kaagad na summation of forces vertical ay 0. So, putting this one into the original beam, ito yung mga values na nakuha natin. Here are the reactions. So, you can check the validity of the summation of moment using these values. Okay? And for our last example, okay, determine the reactions of the beam knowing that support C has a settlement of 25 millimeters. Use slope deflection method. Okay, so ayan, mayroon ng settlement yung isang reaction or isang support rather. Okay? So first, kunin muna natin yung mga fixed end moments. Madali lang yan sa inyo guys, no? Kapag uniformly distributed load, WL squared over 12. Okay? And for a concentrated load at midspan, PL over 8. Alam na natin yan, na. Now, kung gagawa tayo ng cord, okay, connecting this one, okay, kasi nga may settlement, no? Ito yung tinutukoy niya na 25 mm, no? Hindi lang natin masyado na specify. Okay? Hindi po yan yung elastic curve. Yan yung cord na nagko-connect sa points B and C and E. Okay? So now, let's put that into shape. No? Take note na dun sa ating sign convention, counterclockwise ay positive. Tandaan nyo yan, ha? Okay. So here's our slope deflection equations. Delta 1 will be equal to 0. Okay? Bakit? Kasi pantay yung A tsaka B. Okay? Then substitute the pertinent values, fixed moments, then the lengths, etc. Ayan. So nilagay natin yung delta ay in terms na ng meters. So yung 25 millimeters, nilagay natin siya rito as 0.025 meter. Okay. Why is it sa moment BC at moment CB rather, negative yung 0.025? That's because if you connect points B and C, nag-rotate ka ng clockwise. Kaya negative yung ano dito, yung delta. On the other hand, from point C to point E naman, counterclockwise rotation. Kaya positive si 0.025. May po ba yun? Okay. So, konting simplification lang. Okay, this will yield to these equations. For our compatibility conditions, again, dahil fixed support yung mga yun, theta A is equal to 0. Moment BA plus moment BC is equal to 0. Moment CB plus moment CE is equal to 0. And theta E equal to 0. So, theta A, theta E, 0 dahil nga fixed support yon. So, wala na itong mga values na to. This will reduce to this one. Okay. Now, i-add natin itong dalawang to. Okay, yung MBA tsaka MBC. Okay, that is what? EI theta B plus EI theta C over 4 plus 3EI over 1 280 equal to 0. So as with these two equations, this will yield to this one. Okay. Kaso, kailangan nating i-substitute yung value ng E tsaka ng I dito sa equation na to. So nilagay ko na rito yung mga values na naka-convert na into kilonewton and meter respectively. So we can see that 3EI over 1 280 will be equal to 131.25 kilonewton meter. Take note guys, ang aim natin dito na makuhang value ay in terms ng kilonewton meter. Kaya kailangan consistent tayo sa units. Okay, palitan natin yung mga yan. Yan. This time around, gamitin ulit natin yung panggitnang equations, yung may theta B tsaka theta C. And solving the values of EI theta B and EI theta C, we get these values. Negative 152.444 for EI theta B and 84.778 for EI theta C. Setting it aside here, substituting again to the slope deflection equations, we get these values. So, kung mapapansin ninyo, MBA tsaka MBC, same ng magnitude, mag-iba lang ng sign, so as with MCB and MCE. Okay, punta tayo sa ating superposition. Ginawa na natin to kanina, so hindi na to mahirap para sa inyo guys. Simple statics lang to. Then, apply natin yung mga moments na nakuha natin. Considering its sign conventions. Makinig po ng maigi, no? Lahat ng counterclockwise dito, positive. Lahat ng clockwise ay negative. Okay po ba tayo dun, guys? Okay? So, for span AB, definitely, 182.889 is larger than 68.556. So, mangingibabaw yung clockwise moment, kaya counterclockwise to. Ito, parehas naman counterclockwise. So, clockwise yung couple, then parehas clockwise, counterclockwise yung couples. Okay? 182.889 minus 68.556, kung ilan man yun, divided by 8, we get this 14.2917. Next, 182.889 plus 28.861. That sum, we will divide it by 8. So, here's our value, 26.46875. And lastly, for CE, 28.861 plus 170.056. That sum divided by 8. We get 24.8646. So, just like what we did dun sa ating first example, i-add natin itong dalawang to. Take note of the direction of the arrowhead. We get 65.7083 kilonewtons for reaction at A. For B, i-add natin lahat to, taking consideration the arrowheads. We have 200.7604. For C, 58.6667, and for D, obviously that is 54.8646 kilonewtons. So, greatly naapektuhan dito yung reaction sa C dahil nga nandun yung settlement. So, making it into this one, lagyan natin yung mga moments muna, just like this, and here's our reactions. Okay, given that yung settlement sa point C or sa support at C 25 millimeters, any other magnitude of the settlement will yield to other values of reactions. Okay? So that ends our discussion for beams. This time, I would like the opportunity to promote Civil Engineering Twilight. The Engineering, Mathematics, and Applied Sciences Review Book consists of these following subjects: algebra, trigonometry, geometry, vectors, differential and integral calculus, differential equations, probability and statistics, engineering economy. Mechanics consists of statics and dynamics, physics, and strength of materials. It has a conventional solution and an alternate solution to selected problems. For more inquiries, please visit our Facebook page, facebook.com/CE-Twilight, or that is Civil Engineering Twilight, na yung title niya. Ano pang hinihintay niya, guys? Grab a copy now. Please don't forget to subscribe and hit the notification bell. Thank you very much.